All right, guys, I'm going to be talking really fast through this. I apologize. This is a lot of notes, and we need to get through them. This is a very long unit. Matter. What is matter? Matter is anything that has mass and it takes up space. So we're going to go over what mass and volume are so that you can help to understand matter. Matter is basically how much stuff you have in you, or the object that we're talking about. So mass is the amount of matter. How much of it is in whatever object we're talking about. It's the same no matter where you are in the universe. However, weight is different. So people use those interchangeably. They're technically wrong. Your mass is how much you have, and the weight is how much it's affected by gravity. So gravity on different planets affects your body differently. It pulls more on it in other places. So you'll notice in the picture that your mass on the moon and on Earth are the same, but your weight is different because gravity is different on those two planets. The moon is not a planet, but you get what I'm saying. Okay, so volume is the amount of space that is taken up by an object. How much space is in here within the box? Now, we measure them by liquids. We're going to measure using graduated cylinder. We'll use the meniscus, which is just the bottom of this. So we'll practice with that. I just want you to get familiar with that word. Regular solids, like if I just wanted to measure a box or a rectangle, I'd use length times width times height. Irregular solids, like if I wanted to measure an eraser or something like that, I can still use a graduated cylinder, and I would just measure how high the water goes up after I put the eraser into the graduated cylinder. We'll practice this. Okay, so density. This is a really important concept, and I want you to really understand it going in because it's not going away in science. It's going to be there forever. So anyway, notice these two boxes. There's the same amount of space. These are the exact same size box. But in this box, there's way more stuff. There's way more matter. There's more mass in this amount, in this amount of space than this one. This one only has 5 little boxes or 5 little circles. They have a lot of room to move around. Sorry. So this box right here is more dense than this one because in the amount of space, there's more matter. There's more mass. These two boxes right here, they have the same amount. They both have 5 circles. They have the same amount of matter in their space. However, the amount of space in this box is way less than this box. Therefore, this is more dense. Okay, so when we calculate density, we divide the mass by the volume. We have 2 units for that we will practice with, which is grams per cubic centimeters. This is for solids, and grams per milliliters, which are typically for our liquids. Now, I want you to try these 2 problems, just given the equation up here, and let me know which one is more dense in your notes. Okay, so this chart hopefully will be able to help you a little bit because I'm not always going to just ask for the density. Sometimes I'm going to want to know the mass or the volume, and I'll give you the other 2 items, but you got to move your equation around. This chart does that for you. If you want a copy of this, just let me know and I can get that for you guys. Okay, so matter is not always in the same state. It doesn't always look the same. So we have actually 4 states of matter. One of them is plasma. We're not going to talk about plasma. It's beyond gas. It's actually a charged gas. It's what lightning is made out of. But we're going to focus on liquids, solids, and gases. Okay, so solids, notice this box right in here. They did not form to the area around it. It's rigid. It's stuck that way. Now, all of the molecules that are in any item that we're talking about, they're constantly moving around. Those in solids, however, can only really kind of vibrate because they're so tightly packed in there together that they can't really move around much. They're just kind of shaking a little bit. You'll never be able to feel that because they're so small, but they are. And so for solids, we have a definite shape. It's not going to change. unless we do something to it, and we have a definite volume, and we'd be able to calculate that by taking the length times the width times the height. Now, for liquids. Liquids are still very, very close together. Notice that they're showing the molecules in here as very close together. They're kind of just sliding past each other. Because they have a little bit more room to move around, liquids are going to form to the shape of whatever they're poured into, their container. And so they slide past each other, but they have a definite volume. Say I take a bottle of water and I pour it into a cup. It's not going to be the shape of the bottle anymore. It's going to form to the shape of the cup. However, it's still going to be the same amount of water. So we have a definite volume. No definite shape, but we have a definite volume. Gases are moving around all crazy all the time. They're little freakazoids, and they're not rigid. They have no definite shape, and they have no definite volume. They're free. Okay, so freezing point, I feel like I don't need to go over this. It's when a liquid changes into a solid. It's the temperature when it happens. That's it. Boiling point, the temperature in which the liquid becomes a gas. Again, I don't really need to go over that. The melting point is when the solid becomes a liquid. They're just the exact point, the exact temperature when they do these things. Okay, so all of the matter, it can change from one phase to the next. It can change from a solid to a liquid to a gas, which you guys have seen. And so freezing and melting, don't need to go over those. Condensation, this is one that you have seen. I'd maybe not necessarily fit the word to it, but when a gas becomes a liquid, think about on a hot day with a cold drink, and on the outside of your drink, outside of your cup, liquid starts to form. What's happening is the gas that's in the air cools down and sticks to the side of your cup and becomes a liquid because the temperature was low enough for it to become a liquid. Sublimation is when a solid becomes a gas and it totally skips over the liquid phase. And evaporation is the phase change from a liquid to a gas, like when you are cooking and you are trying to cook ramen and you leave the water on for too long and forget about it and all the water is gone because it evaporated. Okay, so a couple words that I need you to know. A solvent and a solute form a solution. These are very easily confused. You've got to keep them straight. The solvent is the substance in which another substance is being dissolved into. Basically, the universal solvent is water. Always think of solvent as the water. Like when you dissolve Kool-Aid and sugar into something, you're dissolving it into water. It's the solvent. The solute, being your Kool-Aid and your sugar, is the substance that gets dissolved. And solubility is the ability of the solute to be dissolved. Can it be dissolved or not? Sugar can be dissolved into water. Salt can be dissolved into water. Oil cannot be dissolved into water. It has low solubility. Okay, so the properties, we have physical and chemical properties. The physical properties are the characteristics that we observe without changing the substance. So we can observe the color, we can smell it, we can taste it, we can get the temperature of it, we can get the density or the boiling point. All of these things, we're not changing it, we're just getting observations about the thing. Physical changes are things that affect the size and the shape. So we're not changing the actual substance, we're just changing something like the size or the shape. We freeze it, melt it, we dissolve it into something, we cut it, or we crush it. We're not changing the actual substance. We're just changing the shape or the size. Okay, so there are also chemical properties and changes, and chemical properties are it's the ability to go through a chemical change. So the pH, if it's acid or a base, the reactivity how reactive it is. Like some things are really reactive with water. The concentration, basically like how much is in a certain amount of space. In the chemical composition, what's it made out of. Chemical changes, and this is not the right thing. I'm sorry, I will correct that in the slides. And so chemical changes are when we actually change the substance into something else. So flammability, we burn it. Rust forms, that's from oxygen and iron that react together to change into something else. Cooking is a chemical change. Like when I cook a steak, I can't change it back. I can't uncook my steak. It's there. It's done. And malleability. Malleability is the ability to form that solid into sheets, like foil, or these are gold sheets. Aluminum foil is a great example of malleability. So a physical change, as you can see here, is cutting the wood, and chemical change is burning it. We change it into something else here. If we left this to burn, it would eventually all burn up, and it would be ash. Okay, so clues for a chemical change. Color changes, like in the apple here. Notice how the color is changed. There's a heat change. This is an example of rusting. Burning is a chemical change. We've cooked the toast. We can't cook it back. Change it back to this. It's not going to happen. Okay, so chemical changes are changing the substance into something else. That's what should have been on that slide right here. Okay, so the last thing that we need to talk about are elements, compounds, and molecules. Elements are pure substance that can't be separated into a smaller substance. So all of those elements on the periodic table they can't be separated into something smaller without losing their identity. So copper is an element. Zinc is an element. Gold, silver, magnesium, sodium, those are all elements in their simplest form. Now, elements can be combined to form compounds, which are chemically bonded together. Water is H2O. That's hydrogen and oxygen together chemically in a set ratio. It means there's a certain amount. There's 2 hydrogens for every oxygen. Salt is sodium and chlorine combined together. There's a 1-to-1 ratio here. So they're chemically bonded. Mixtures are combos of 2 or more pure substances that are not chemically bonded. Put a big circle around that. They're not chemically bonded. They're just held together by physical forces. So like held together in a cup. This is an example up here in this picture. Tap water. There's a ton of stuff in water. Tap water that comes out of the sink, there's so much stuff in there. Like you've heard about fluorine being in the water to help with cavities. It's not pure water. This would be an example of pure water. Notice how it's all exactly the same. There's a bunch of other crap in here. Each of these items retains its own identity. They're just kind of stuck together. Kind of like you guys in class, and you all have your own identity, but you're in the same place. You're not all the same. Okay, so there's homogeneous mixtures. The substances are not evenly distributed. Look at this salad down here. I can see that there's way more lettuce, then there's some tomatoes, and there's some chicken, and a bunch of other stuff that I don't know what it is. But you can tell that all these things are separated. In this tea right here, you can see the lemon, there's ice, there's the water, there's the tea, there's this little mint, I don't know. Anyway, and then these are mixed up. I'm so sorry. These pictures are supposed to be over here. These are supposed to be heterogeneous mixtures. These are homogeneous mixtures. Again, I will fix that in the notes. I'm very sorry. You shouldn't be taking notes off this video anyway. You should just be watching it. So heterogeneous mixtures they're different. You can see that. Homogeneous mixtures, they look the same. We've combined them, and they, like the Kool-Aid down here, combined with the water and the sugar and the little powder to make a homogeneous mixture. This is just a flow chart to help you. There's matter. It's a pure substance. We have elements and we have compounds. Compounds are just combinations of elements. The mixture is heterogeneous, there's a bunch of different ones, or homogeneous, where they are